Hello, good people, and welcome back. And here we are going to start with Unit 10. And Unit 10 is going to be on the properties of stock options. Now, what I'm going to be doing in these slides is essentially, in this unit, is essentially working from the board mostly, which is over here, versus doing much of almost any work here at all. All I'm going to do on the slides are going to be introductory material, and to actually develop the relationships that are the target here, I'm going to be working entirely on the board there. So keep an eye on that, and I'm actually not going to discuss the slides much at all. I may come back to the slides to highlight a couple of facts. But the derivations of all of these, I'm going to be working on them over on the notes, and that's going to be how we approach this chapter. It's going to be, or this unit, it's going to be a lot more conceptual than usual. All right. Before we get started, we know what options contracts are: right to buy or sell, and on the line at a specified price at some point in the future. And we've done this quite a few times. We've also developed strategies that utilize those options. So we're pretty comfortable with options by now. We're going to touch on a couple of notations before we get started here. Lowercase c is going to represent European call option price. Capital C is going to be an American call option price. Lowercase p is European put option price. Capital P is going to be an American put option price. S0 is going to be a stock price today. ST is going to be stock price at some point in the future. K is going to be our strike price. T is going to be the life of the option. D is going to be the dividend or the present value of the dividends during the option's life. Sigma is going to be the volatility of the option, the stock price. That's down the line. And R here is going to be our risk-free rate of return. That's assumed to be continuously compounded. In addition to all of this, we're going to make a couple of assumptions. One of the first assumptions that we're going to make is that there are no transaction costs. So no transaction costs, no cost of buying or selling down the line. The second assumption that we're going to make is the idea that taxes are identical. When we say taxes are identical, it means that I pay the same level of tax that you pay, that Warren Buffett pays, and everybody else. So it's a simplifying assumption that allows for this to apply to any situation. And one of the last assumptions that we're going to make is that this interest rate that we're using here, which is the risk-free rate of return that is continuously compounded, is both our borrowing rate and our lending rate. So if we're borrowing in this market, we're borrowing at the risk-free, and if we're lending at all, we are lending at the risk-free. Alright, so we're going to move back to the board and try to set up some work that we're going to be doing. And one of the first things that we're going to be doing here is characterize the relationships between the spot price of the underlying, the interest rate, the volatility of the underlying, or the standard deviation of the underlying, the maturity of the option. That's going to be, I'm going to make it a little bigger there. The maturity of the option. We are also going to be working with the strike price, try to understand that relationship that the strike price has with the option premium. And finally, if at all there are any dividend, we also need to look at those dividends, and so we're going to be using looking at dividends. And the way we're going to approach this is essentially, I'm going to scoot this down a little bit so I can squeeze up here. Then I'm working with a call option or a put option. And I'm also going to say, well, label this lower cases, so lowercase, and capital case, right, or uppercase. And this is going to be European, so maybe I should say European here, American here, American option. Alright, so what are those relationships like? Well, if we're working with the call option price, we know that the payoff of the call option is going to be the maximum of the stock price at that point in time in the future minus the strike price, L0. And that is at that point in the future. And so if we could try to find the present value of this payoff today, that present value of the payoff would be the present value of the stock price. The present value of the stock price is S0, and the present value of the strike price is strike price as discounted at the risk-free rate of return for a period of time T, which is the expiration of the contract. And so if this is understood, that the payoff here is the payoff at expiration, and what we're working with is the value today of that payoff, we can essentially infer what is the price today that we should pay in order to obtain this payoff. And that price for a call option is a call option premium. And so that price essentially is going to be a function of the likelihood of the option being in the money, which is volatility of the option, and also the strike price, the risk-free rate of return, or which is the borrowing and lending rate, the time to expiration, and the location of the spot price. And so if we keep everything else constant and we increase the spot price, holding everything else constant, what we're going to find for a call is that the call price is also going to be increasing. Because if we get rid of this value here, all we have is the following. The call value would be the equivalent of that. And so increasing this term here, which is the stock price, keeping everything else constant, would increase the call value. So we can have a positive sign here and a positive sign there. Now, changing the value of, if we're working with a put, maybe I should have that for the put as well. What we have is a payoff that's equal to the maximum of the strike price minus the stock price at that point, or 0. And so the value of the put today would be the present value of those terms there. So we would have the present value of the strike minus the stock price S0. And that is of today. And so increasing the stock price here would mean that we're increasing this side of the expression, which would deplete the value of the put option price. So that would have a negative value here and a negative value there. So increasing the stock price would decrease the put option premium. Now, how about the interest rate? If the interest rate were to increase, what will happen here? Remember, here we're working with, actually it's a negative there, we're working with the present value factor. So if we interest rate increase, what that means is that the discount rate is going to be increasing, and if the discount rate is going to be increasing, the present value term here is going to be lower, and the lower the present value term, the lower this side of the equation. So we're going to have stock price minus a lower second component here, which means that the call option is going to be increasing. So that's going to be increasing here, and it's also going to be increasing for the American call. How about the put option? So if the interest rate increases, the present value of the strike is going to be decreasing, which means that the put option price is going to be decreasing as well. So we can have a negative sign there for our put option price and a negative sign there for our put option price here as well. The volatility of the option of the underlying is always going to be positively related with the call option premium or the put option premium, and the reasons for that is the more movement we have in this value, the more likely, because the standard deviation captures the movement that we have in the value of the underlying, the more movement we have in this underlying, the more likely it is that the option will be in the money. And so we want to have a lot of movement here. The same here, the more movement we have in this value here, the more likely it is that the option is going to be in the money. So what we're going to have is a positive sign across the board here. Now, with respect to time, it's going to be a little tricky. With respect to time, a European call can only be exercised at expiration, which means time doesn't change, and so time is completely unrelated to the value of the call option or the put option for European option contract. So we're going to put question mark here and question mark here, just to suggest that for the same underlying in the same contract, time doesn't change. Time is a fixed value. So we really can't determine that. Now, if we have multiple contracts on the same underlying, the effect of the time to expiration is a function of whether there is an income that is expected from the underlying or not. And so as a general rule, we say, well, as time is invariant for European call option or put option premium, the time has nothing to do with the valuation or the pricing of these contracts. However, if we're working with an American call or an American put option price, those options can be exercised on or before maturity, and because they have the option of being exercised before maturity, time is a factor, because time might be variant there, time might change. And so the higher, the longer T is, the more likely it is that the option could expire in the money. And so the higher T is here, the lower the present value is going to be, and the lower the present value, the higher the call option premium. So it's going to have a positive sign here, and the same would apply for the put option price. And the more likely it is that the option would expire in the money, so we're going to put a positive sign here as well. Now, when we're working with the strike price, the strike price is essentially going to have the opposite behavior of the stock price. So for a call option price, if the stock price increases, typically we want to have the relationship between the strike price and the call option premium is going to be negative, right? As the strike price increases, the less likely it is that the stock price is going to be increasing enough to go past the strike price and make the option in the money. So the higher the strike price, the more difficult it is for the option to be in the money. So we're going to have a negative sign here for a call option, and we're going to have the negative sign there for the call option as well. For the put option, on the other hand, the higher the strike price, the better, because the higher the strike price, the more in the money it is that the option contract is likely to be. And so it's going to be a positive sign there and a positive sign there. Now, dividends play the role of income that are received, and dividends typically tend to depress the stock prices. And so because dividends decrease stock prices, they're going to have the opposite effect that stock prices are. So when stock price increase the value of a call option, the European call, dividends are going to be decreasing the value of the European call. And when stock price decrease the value of the European put, dividends are going to be increasing the value of European puts. And the same here. Now, to clarify the idea with dividend again, you remember that when we worked with futures, we said futures is going to be equal to the spot minus any income, right? And then we said future value. We said that income here for futures contract was essentially the present value of the dividends. Now we call that present value of dividend D. And so that present value of dividend depresses the stock price here just as it does for futures contract. And so it's going to have the opposite effect for the call option premium because it's going to decrease this value of stock price. So for the call, we would have stock minus dividend, and then we're going to have minus future value or present value of the strike. And that's going to be what we would have here. And that would deplete the call option premium. That's why we have a negative sign here. For the put, it's going to reduce this value here and make sure that and lead to a positive outcome for the put option premium. All right, so these are the basics here for what the relationships are between the variables that help compute the call option premium or the put option premium and those premium themselves, right? So as stock price increase, call is going to be increasing, but put is going to be decreasing. That's that. As stock price, as interest rate increase, call is going to be increasing, but put is going to be decreasing as well. As volatility increases, call and put are both going to be increasing. With respect to time, it is an unknown for European options, but it's a known behavior for American option, and it's an increasing relationship between time and call and put option premium for American options. When the strike price increases, the value of the call option price decreases, whereas the value of the put option price increases. And when dividends increase, what we have is the call option decreases, whereas the put option increases. Now, that sets up the remainder of our discussion. We do have at this point a clear idea of what the relationships are between those parameters. What we want to do now is we want to kind of infer what are the boundaries, what are the limits within which we should observe a movement in the value of the call option or the put option premium. And the way we're going to approach that is by applying a concept that we've looked at a while back or a few times over, which is the no arbitrage. So we're going to assume that no arbitrage exists. And I want you to follow this very, very carefully as we describe this process. So what I'm going to do here is I'm going to assume that there may be an arbitrage opportunity, and we're trying to figure out essentially what are the scenarios that would lead to an arbitrage opportunity or that would create an arbitrage, and what are the scenarios where an arbitrage is not going to exist. And then we are going to define those boundaries building on those no arbitrage scenarios. Now, let's say we are working today and we have a stock price today that is S0. We have a strike price on a call option, and that strike price is K, and that strike price is going to be paid at some point in the future, which is T. Our interest rate is R over the life of this agreement, this contract. What we want to do is we want to see if we can construct some form of arbitrage. And the way we're going to approach this using calls for now. So I'm going to say calls here. Using calls, could we construct a form of arbitrage here? And what would that arbitrage look like? Well, the way I would go about this, I would think about what does a call allow you to do? Well, the call gives you the right to buy. And so if you're going to arbitrage with a call option, you essentially don't want to own the underlying because you're going to be buying the underlying at some point in the future. And so what you want to be able to do is you want to be able to accumulate capital today that's going to be invested and use at some point in the future in order to acquire, because you're going to buy in order to acquire the underlying. And so to raise the capital that you need today in order to invest it and have some value in the future that is then going to be used to exercise the call option, what you're going to do is you're going to short the stock today. And so that's what we're going to do. We're going to borrow the stock and then we're going to sell it. Now when we sell the stock, what do we get? When we sell the stock, we get plus F0. That's why we sold it. At the same time that we're selling the stock, we need to take a long position in a call that would give us the option at some point in the future to buy back the underlying and return it to its owner. So we are also going to go long call. And our long call simply means that we're going to be paying minus call option value there. So we bought a stock, we bought the stock, we sold it at S0. We used some of that sales money in order to purchase a call option, and whatever is left, let's call that value A. That's whatever is left for us to use after we spend the money to buy the call option. Now, what do we do with this money? We invest it for a period of time T until we get a future value. So we invest it at the risk-free rate of return for a time period T. Now, an arbitrage would exist here if I'm able to make a sharp profit by getting this amount of money that I am able to generate here and buy back the stock, return it, and still have some money left after. So make a sharp profit from this transaction. Now, what are the scenarios that we can observe at that point in the future? Well, the scenarios that we can observe at that point in the future might be as follows. We might have a scenario where the stock price in the future is essentially less than the strike price. We might have the scenario where the stock price is equal to the strike price, or we might have the scenario where the stock price is greater than the strike price. Now, at the same time, we might say, well, if we have this much money in our account at time T, how does that money compare to the strike price? Let's say we were to exercise the option, would we have enough to actually buy the underlying? And so the way we want to think about it is to say, well, does this value here, a future value, is that value less than the strike price? Is that value A, future value, equal to the strike price, or is that value A, future value, greater than the strike price? And we're going to look at all these conditions, and we're going to emphasize those scenarios where no arbitrage would exist. And so the first scenario we're going to look at is the following. What if what we have in our account is greater than the strike price, is less than the strike price? If that is less than the strike price, it means that exercising the option would essentially we wouldn't have enough in our account to exercise the option. Why would that be? The option gives us the right to buy, and to buy we have to buy at the strike price, and so we would not be able to have an arbitrage opportunity here because we don't have enough, at least at this point, to exercise the option. Now, this would be true, but then again, what if the stock price indeed here is also less than the strike price? So if the stock price is also less than the strike price, what we have is a scenario that where we may not have to exercise the option, but we may just go ahead and buy the stock out on the open market. And so the only time an arbitrage opportunity would exist in this scenario is if the stock price TST is actually less than the future value of A. Because when this is true, what's going to happen is we're going to use this money and buy the stock back at ST in the open market without having to exercise the option, and then retire it or return it to its owner. So at this point, there is an arbitrage opportunity. When this value that we have here, A future value, is greater than the stock price, we can arbitrage away and we can have a sure positive profit. Now, what if the stock price is actually equal to the strike price? Let's see if the stock price is equal to the strike price. Well, if the stock price is equal to the strike price, what we're going to have is a scenario where the future value here is going to be less than the stock price, is also going to be less than the strike price, which means that what we are going to be able to do is we are not going to be able to have enough to buy back the stock, and we are also not going to be able to buy back the stock in the open market. We are also not going to be able to have enough to exercise the option. So there is no arbitrage that could exist here. What we're going to do, we're going to say there is no arbitrage here. Next, what we're going to look at is a scenario where we have the stock price that's higher than the strike price. Well, if the stock price is higher than the strike price and the strike price is higher than the future value of our account here at maturity, what we're going to have is the following. We're going to have A future value is going to be less than the strike price. That's what we have according to this expression. But we also know that the stock is less than the strike price. So stock is going to be less than the strike price. The stock is also going to be greater than the strike price. And so in this case, again, we don't have enough to buy the stock in the open market, and we also don't have enough to exercise the option. So there's also no arbitrage opportunity that exists here. So far we've identified 2 scenarios where there is no arbitrage opportunity. How about the third one up here? When this is equal to the strike price, what do we have? Well, in that event, we say, well, we could exercise the option, because if we exercise the option, we would be using this money that we have generated here to buy back the stock and return it. However, if we did that as is, we would not be able to realize a sure profit. Remember, arbitrage for us would mean that we have some money left after we repurchase the stock and return it. At this point, if we exercise the option, we use everything to buy back the stock, and therefore there is nothing left, which means that at that point there is no arbitrage. Now, what if the stock price is actually less than the strike price as well? In that case, what we're going to have is a scenario where the stock price is going to be less than the strike price, but the strike price itself is equal to what we have here, which means that the strike price is also going to be equal to this future value term here. So what that means is, although we cannot, if we exercise the option, we would essentially be using everything in our account, right? But if we purchase the stock in the open market, because this value is essentially higher than the stock price there, we may be able to realize a sure profit. So there could be an arbitrage opportunity there, because this relationship here and this is essentially the same that we have here. So there's an arbitrage opportunity that exists here. Now, what if the stock price is equal to the strike price? Well, in this case, what we have is the future value of our account is exactly equal to the strike price, and that's also exactly equal to the stock price. Well, at that point, we may be able to buy back the stock and return it, but there will be no arbitrage opportunity, right? Because there is no sure profit. The outcome there is equal to 0. Arbitrage by definition suggests that we can make a sure profit with no investment of ours. So there's no investment of ours, but we don't make any money. So there's no arbitrage opportunity here as well. That's going to be our third scenario. Next, what we're going to look at is a scenario where the stock price is actually higher than the strike price. Well, in that case, what do we have? Well, we're going to have the following. We're going to have the future value of A is going to be equal to the strike price, but that is also going to be less than the stock price. Well, what does that mean for us? What that means is, if we use everything in our account, I'm going to use a different color here, that's just to make it. If you use everything in our account and we exercise the option, we don't realize a sure profit, right? However, we cannot use what we have in our account to purchase the stock in the open market, because what we have is not enough to purchase the stock in the open market. And in that case, there's no arbitrage that exists here. So we are also going to flag this as a no arbitrage scenario. That's going to be a 4 here. Now, what if the future value of our investment is higher than the strike price? Well, if the future value of our investment is higher than the strike price, what do we have? We have a scenario where we could use what we have, buy back this, exercise the option, right? And once we exercise the option, we still gonna have something left, and so that would constitute an arbitrage opportunity. Now, how does that compare to a scenario where the strike price is also higher than the stock price? Well, it doesn't matter. We have two ways in which we can exercise the option. We can buy back the stock. We can either buy it back by using the option, or we can simply buy it back in the open market. And so if we bought it back using the option, we would be buying back at strike price. If we bought it back using the open market, we will be buying back at ST, which is even lower than strike price. And so there will be an arbitrage opportunity here, because what we have is the future value here is greater than K, which is also greater than ST. So yes, there is an arbitrage opportunity here. Well, the next scenario is we have enough to buy back in the open market to exercise the option, which means that A future value is going to be greater than K, and K is equal to the stock price. So A future value is also greater than the stock price. So we could exercise the option or we could buy it in the open market. We would have an arbitrage opportunity that exists there. And finally, we know that our stock price is greater than the strike price, and the future value of our investment is also greater than the strike price. So what we're gonna have is something maybe like this, where A future value is gonna be greater than the strike price, is gonna be greater than the stock price, but it's also greater than the strike price. Or we're gonna have stock price that's greater than A future value, which is also greater than the strike price. Either way, we can exercise by buying in the open market or exercising the option, right? We can buy back the stock by purchasing the open market or exercising the option, or we can purchase the stock back by just exercising the option. So there is an arbitrage opportunity that exists there. Now, overall, what do we have? Overall, we have these scenarios. We have a scenario where what we have in our account is either less than what we have in our investment is either less than or equal to the strike price. So we're going to say A future value is either less than or equal to the strike price. But we also have the scenario where the stock price is either greater than or equal to the strike price. So the stock price is also greater than or equal to the strike price. So it's going to say greater than or equal to the strike price. This is essentially what we're going to have. This relationship here is what we have above. This relationship here is what we have here. And that gives us all four scenarios. So that's where we do not have any arbitrage opportunity. Alright. Now, let's take these first two components. Well, for the first two components, what do we have? We have A, which is whatever we have left, future value, is less than or equal to our strike price. What does that mean? It means that A is going to be less than or equal to the present value of our strike price. All I did is multiply by by the present value factor. And what was A before? Well, A was what we had left after we purchased the stock and we essentially spend money to buy the call option. So A is going to be equal to stock minus call, less than or equal to the strike present value. Now, what that means for us is that minus call is going to be less than or equal to the strike present value minus stock, and we're going to multiply this by minus 1, and we're going to multiply this by minus 1. And when we do that, what we essentially obtain is call is going to be greater than or equal to stock price minus present value of the strike. So this is the first relationship that we need to remember. Alright, with that being done, the next step for us is going to be to say, well, how much, what is the maximum price, because this is going to be a lower bound, right? Because that says that the stock price minus the present value of the strike price has to be less than or equal to the call premium. Well, what is the upper bound of this relationship here? Well, it turns out that intuitively you would say you wouldn't pay the value of the stock today to have the right to buy the same stock at some point in the future. So if the stock is worth $100 today, the call option premium cannot be worth $100 because you would just buy the stock outright. All right. So why would you buy the call at $100 when the stock itself is $100? What the call does, it gives you the right to buy the stock at some point in the future. And so purchasing the right to a stock at some point in the future cannot be worth more than the value of the stock today. So the upper bound is going to be S0. That gives us essentially the boundaries for our call option premium. And that would be for a non-dividend paying stock. So this would be for a non-dividend paying stock. Now, if the stock does pay a dividend, what do we do? How do we adjust this to reflect the fact that the stock actually does pay some dividend? Well, the way we can adjust that to reflect the fact that a stock does pay dividend is by, of course, correcting the value of the underlying to capture that dividend payment. And so that correction would essentially be as follows. It would essentially be that the stock price will be corrected for the present value of the dividend, and then we're going to have the strike price present value, and that has to be less than or equal to our call premium. And of course we would have stock price minus present value of dividend here as well. So this would just be a correction of the stock price for the present value of the dividend from the expression that we have above here, and that would be for a dividend paying stock. So we can define the boundaries of the call option premium. We could replicate this whole thing, this whole process, and try to see what the arbitrage would be like if we were to use a put option this time for arbitraging. Well, if we are to use a put option, what does the put allow us to do? It gives us the right to sell. So with the put, we have the right to sell, which means that we want to own the asset today so that we can sell it at some point in the future. And so the way we're going to own the asset today is by borrowing a value A here that would allow for us to buy the asset today by spending S0 to buy the asset, and also at the same time take a long position in a put option contract. So minus put option, that would be minus A, well, that would be S0 plus P. That's what we have, and then we're going to use this to purchase the stock and purchase the put, and we would deplete essentially our borrowing. Now at some point in the future we would have to pay a future value. That's a payment that we'll have to make, and then we need to analyze the scenarios where an arbitrage opportunity would exist so that we can generate enough to pay off this loan and have something left over after we buy. We're able to essentially sell the underlying that we purchased initially. So we buy the underlying here, that's why we spend P S0, and we also buy a put option contract, so we long put there. We have the right to sell, and what we want to see is by exercising the option or selling the underlying in the open market, are we able to generate this, at least this much, or more than this? So if we're able to generate more than that, that creates an arbitrage opportunity. If we're not able to generate more than this from the sale of this stock that we purchased, by exercising the option or not, then the arbitrage opportunity doesn't exist. And so the process would be the same, and the outcome that you would obtain if you were to to do just that and replicate the work that I just did here for a call, you would essentially obtain the following. You would have the strike price present value minus the stock price would be less than or equal to our put option premium, which would be less than or equal to the present value of the strike. And that would be those would be the boundaries for a non-dividend paying stock. And of course, whenever you're working with a dividend paying stock, all you need to do is make that adjustment for S0, so S0 minus D, and that's essentially what you would have there. And no adjustment would be made up here because there's no stock price value there. Alright, so these are going to be our boundaries for a call option premium and a put option premium. If those boundaries are not respected, an arbitrage opportunity exists. However, our principle says there's going to be no arbitrage because whenever an arbitrage opportunity exists, there are arbitrageurs that are going to step in and try to take advantage of the arbitrage opportunities. And by doing so, they're essentially going to eliminate the existence of those arbitrage opportunities. Alright, so next what I want to talk about is the put call parity. And the put call parity, I'm just going to describe what the relationship is like. We're not going to essentially derive the put call parity here, but what we're going to do is in the next unit, when we're going to look at the valuation of option contracts, we are essentially going to infer what that put call parity, or suggest to you where the put call parity comes from. But the put call parity is essentially defines the relationship between put option value and call option value. And our put call parity is going to say the following. Put call parity, and what that's going to say is that the call plus the present value of the strike is going to be equal to a put plus a stock price. So if you construct a portfolio that has a zero coupon bond, which is that is this that's invested at, that is this value here that's invested at an interest rate of T for a period of time K, and that's going to yield K at the expiration maturity. That's essentially a zero coupon bond. If we have a zero coupon bond, and in addition to the zero coupon bond we take a long position in the call, the payoff that we obtain is exactly the same payoff as we would obtain if we were to take a long position in the put and a long position in the stock. And I think there's an example of that in on the slides that we're going to look at in a little bit. This put call parity applies only to European option. And the reason that apply only to European option is because American option have additional embedded option built into them, in that they can be exercised early. And so with American option, we need to make an adjustment. The equality there doesn't hold, or doesn't always hold. With an American option, what we have is the following. We have our stock price minus our strike price is going to be less than or equal to the call minus the put, which is also going to be less than or equal to the stock price minus the present value of the strike price. This would be essentially the equivalent to our put call parity for an American option. Or for American options. Alright, so this is gonna wrap it up for us. Again, with respect to this, whenever we make an adjustment to the dividends, we need to correct for those values, especially here. And actually, maybe I should expand this a little bit. So if we are making an adjustment for for dividend here, what we would have is present value of the strike, and then we're going to have minus S0 plus D less than or equal to P, which is our put option value, less than or equal to the present value of the strike. Right, and the reason I wanted to emphasize this is because of this positive sign with respect to the dividend there. And that positive sign comes from the fact that we have this negative sign in front here, so that the negative sign multiplies by S0 and negative sign multiplies by that negative sign as well. That's where the positive here comes. The positive here comes in. And so this is the relationship that we have there. Alright, this wraps it up for our discussion for this unit. It's fairly straightforward, and it's just a lot more conceptual. My derivations here, the goal there was not for you to be able to redo this, although I want you to try to do this for a put option contract and see what you get. But my goal was to show you what the intuition is when you essentially are trying to find what the boundaries are. You look at the various scenarios, the various conditions that can exist for no arbitrage, and then you group those conditions and you summarize them. And that's what we did. We looked at the condition that could exist. That's this table here that we're able to build, that entire table. And then we summarized the conditions. That was this summary that we made here. And that summary that we made here essentially matches these outcomes. And those outcomes are no arbitrage outcomes. And with no arbitrage outcomes, we were able to derive the lower bound. And we also talked about how we obtain the upper bound for a call option contract. And we could do the same for a put option contract, and that's essentially what we would obtain. We talked about the put call parity for European options, and we talked about a similar parity, if you will, for American options. Alright, so this wraps it up for this unit. I will see you in the next video for what we have on the next unit. And I think the next unit is going to be evaluation, and we'll talk about binomial trace. I'll see you in the next video.